Let's begin Chapter 5. Chapter 5 covers exponential and logarithmic functions. Homework 18 is due on Wednesday, October 23rd. Because this is a recording, remember you can pause, rewind, or change the playback speed at any time. So let's begin 5.1. 5.1 is over composite functions. Feel free to take a moment, if needed, to record the different meanings of each composition. Also note that the open circle symbolizes composites or composition, but that open circle should be a little bit more centered. But in my software program, it looks more like a degree sign, but that is an open circle. And it would look in your textbook more like a letter O that is centered. So I just wanted to clarify that. When you do a composition, you're taking one function and putting it into another. So when you see f of g of x, that means that I'm taking the g of x and putting it inside f of x. G of f of x means put f of x in g of x. We can also compose functions into each other. So f of x means put f of x in f of x, and g of x means put g of x in g of x. Take a moment, pause the screen if needed to copy down these, to copy example 1. So this first one means f of g of 5. So in order to find f of g of 5, they gave us a value. We're going to start by finding g of 5. So we have two functions. We have g of x, and we have f of x. Okay, so we're going to start by finding g of 5. So I'm going to take that 5 and put it inside of my g of x function. So that would be 5 plus 6, which gives me 11. Now I'm going to take that answer that I got from step 1 and put that into the f function. So I'm going to find f of 11, which would be 2 times 11 squared plus 1. And if you type that in your calculator, you get 243. So your final answer that I would be looking for is 243. So now let's find f of negative 3. So I'm using the same function twice. I'm going to start by finding f of negative 3, which would be 2 times negative 3 squared plus 1. And when you type that in your calculator, you get 19. And we're going to take that answer and put it into the same function again. And our final answer would be 723. Pause the video and attempt to do the next question on your own. So first I would start by finding f of 0. And when I substitute that 0 into this equation, I get 1. And then I take that 1 and substitute it inside of my g function. And when I do that, my final answer would be 7. And then for our last example, for our last piece of example 1, we have g of 2. So I'm going to start by finding g of 2. I'm going to substitute 2 into this function. 2 plus 6 is 8. And then I'm going to use the g function again, and this time I'm substituting 8. 8 plus 6 will give you 14. So let's do this again, and this time we're going to use two different functions. Again, feel free to pause the video so you can copy down example 2. So this time I have f of x, which is the square root of x plus 5. And I have g of x, which equals 3 times x. So we're going to start with, you always start with the function closest to my input. So my input is 5, and the function closest to the input is g. So I'm going to start with my g function, and I'm going to find g of 5, which would be 3 times 5, and that is 15. And I'm going to take that result that I got and substitute it now into the f function. So f of 15 equals the square root of 15 plus 5, which is the square root of 20. And we always simplify our square roots, which is going to simplify down to 2 times the square root of 5. And how did I get that? Well, I know that 4 is a perfect square, and it is also a factor of 20. So I'm going to take that 20 and separate it to the square root of 4 times the square root of 5. The square root of 4 is 2, and 5 would have to stay. So this is the final answer for question, or for the first part of example 2. Now let's look at f of 4. So I'm going to use the f function twice. So I'm going to start with, again, the closest function. Well, it's the same function, but f of 4 is closest to my input. So when I use this function, I have that f of 4 equals the square root of 4 plus 5, which is the square root of 9, which gives me 3. Now I'm going to take that 3 and substitute it into the f function again. So that would be 3 plus 5, which is 8. And again, you never leave a radical unsimplified. 4 is also a factor of 8. We're going to break that apart to 4 times 2. And that's going to give me 2 times the square root of 2. And that would be my final answer. Take a moment, pause the video, and try to work through the next 2. So the function closest to my input is -1. And that the f function is closest to my input. So I'm going to start with my f function. And when I use my f function, I'm substituting -1 into our function here. So when we find f of -1, I get the square root of -1 plus 5, which is the square root of 4, and that is 2. Now I'm going to take that answer and put it into my g function. And I'm going to find g of 2. The g function tells us to take 3 times the input. 3 times my input would be 3 times 2, giving me a final answer of 6. And for my last one, I'm using the g function twice. So I'm starting with an input of 2, and I find g of 2. G of 2 would be 3 times 2, and that gives me 6. And now I'm going to take that and substitute it into my g function again. And 3 times 6 is 18. Feel free to pause the video so you can copy down example 3. So now we are going to compose our functions and create a new function while stating the domain. Notice that the input is no longer a number, it's an x. So what this is telling me to do, f of g of x means take my g function and put it inside of my f function. So my f function says x squared plus 1. So I got my parentheses squared plus 1. And I'm going to put that x minus 6 inside of our parentheses. Now, don't forget, when you square a binomial, we have to make a box, FOIL, or distribute. The biggest mistake is students will forget that and say that x minus 6 squared is x squared plus 36, and that is not correct. When you fill in all 4 squares, which I'll give you a moment to do, when you fill in all 4 squares, you get x squared minus 12x plus 36. I'm going to bring down that plus 1, which was at the end of function f. And then my last step would be to combine my like terms, 36 and 1. So x squared minus 12x plus 37 is my function. Now we also have to state the domain, but remember, if you don't have a fraction or a fraction with a variable in the denominator or square root, your domain is all real numbers. And because I'm starting off with 2 functions that don't have red lights, that tells me that all of my functions, when I create them, will all have the same domain. For our next example, I am taking my f function and putting it back into f. So that means right here where I have my input of x squared, I'm going to put x squared plus 1. So I have x squared plus 1, and then my input would be x squared plus 1. And this time when you make your box, you're multiplying x squared plus 1 times x squared plus 1. So that's going to give me x to the 4th, x squared, and 1. When you combine your like terms, you have x to the 4th plus 2x squared plus 1. I'm bringing down that plus 1. And when I add my like terms, my final composition will be x to the 4th plus 2x squared plus 2. And again, our domain is all real numbers. Now for our next piece, we're taking the f function and putting it into the g function. So my g function, so I'm going to take this function here and I'm going to shuttle it over here and drop it right there. The g function is a lot easier to work with because it doesn't have an exponent, so we won't have to multiply any binomials together. So our simplification or our composition will be a lot easier or quicker than our first 2. Let me go ahead and highlight these 2 for my final answer. So I'm going to take this f function, which is x squared plus 1, and put it here. And this g function says take something and then subtract 6. And this is the something that I'm using. So I have x squared So I have my initial function, which is x minus 6. That's my g function. And I'm going to put the x squared plus 1 on the inside. Now, this input in my g function does not have an exponent, or it has an exponent of 1, I should say, and is being multiplied by 1. So there is nothing to change this input. So I can eliminate my parentheses and just combine my like terms. And that would be my final function. And again, my domain is all real numbers because there are no red lights. And then lastly, for g of x, again, I have my x minus 6, and this time I'm putting x minus 6 on the inside. So I'm left with x minus 6 minus 6, which is x minus 12, and my domain is all real numbers. And that is example 3. We have one more example, and then that will conclude day 1 of chapter 5. Tomorrow in class, we will finish out the end of 5.1 and begin 5.2. So take a moment and pause the video so you can record example 4. So we're going to put in this first one, now I'm noticing I have a red light, which tells me that all of my domains will no longer be all real numbers because I have a square root. So for the first question, I'm going to put g inside of f, which means I'm going to take this and put it here. So my function becomes the square root of 3x minus 1. So now we're ready to find our domain. Remember, when we have a square root, it has to be positive. So my domain, I have to set that greater than or equal to 0 and solve that for x. And when you solve that, you should get that x has to be greater than or equal to 1/3. And when we write that in interval notation, we would have bracket 1/3 to infinity. And that would be my domain. So this is my function, and this is my domain. Now, for our second piece of example 4, I am going to use the same function. So I'm going to take the square root of x and put it under a square root, because function f says take the square root of your input, but my input is the square root of x. So we have actually, and this is something that we may not recognize, we have the square root of the square root of x, which is actually the same thing as the 4th root of x. Now we have an even index, so that means our term underneath our square root has to be positive. So because x has to be greater than or equal to 0, because you can't take the square root of a negative, the 4th root of a negative, the 6th root of a negative, the 8th root of a negative. You cannot take an even index of a negative. So our domain is going to be x has to be greater than or equal to 0, or bracket 0 to infinity. And I would take either one of these answers, and this is our domain. Let me go ahead and write domain here, so we'll know what that piece is, and that is our domain. So now we're going to take For this example, remember it says this means take f of x and put it into g of x. So what I'm going to do is I'm going to take this and put it right here. So my function will be 3 times the square root of x minus 1. That is my function. I cannot simplify that any further. I have only an x underneath my square root, so my domain is 0 to infinity. So that's my function, and that is my domain. And then lastly, we're going to take our g of x and put it inside of g of x. So I'm going to use my 3x minus 1, and in place of x, I'm going to put 3x minus 1. So I have 3 parentheses minus 1, and we're going to put our 3x minus 1 on the inside, distribute the 3, and combine your like terms. So that would be my function. I don't have any red lights, so this is the only one that has a domain of all real numbers.